See now the graphs of motion. When the object, this is the first graph that we are taking, the object is at rest. That is, it is not moving. We are considering over here distance time or displacement time graph. Okay, so here you can see over here, this is distance time graph. Here, this is the line, the green line that is there is parallel to x-axis. So this is a straight line parallel to x-axis, or here this is the line that is coinciding the x-axis. It means at all these points, as the time proceeds or as the time progresses, the distance is not changing. This is the graph for the object that is at rest, that is, it is not moving. The next part that we are considering is the speed time or velocity time graph for the same object which is not moving. It means the distance is not changing, it is at rest. So obviously its speed or velocity will be 0. This line is going to coincide the x-axis. So as the time proceeds, there is no change in speed, that is, its speed is remaining 0. This is the speed time or velocity time graph for the object that is at rest, which is not moving. The next part over here for the same one is the acceleration time graph. Because its velocity is not changing, it's 0. So acceleration also will be 0. Whenever the velocity or speed is not changing, its acceleration is 0. The speed or velocity does not change, so therefore the acceleration will be 0. This is going to be the line that will be along x-axis or coinciding the x-axis. The next type of graph that we are considering, the object is moving with constant speed or velocity. The first graph that we are considering is distance time graph or displacement time graph. This is the graph that is for constant speed. When the speed is constant, you can see this line in displacement time graph is going to be inclined, and it is always going to be a straight line. Okay, so it's going to be inclined to at a particular angle. This is the graph that is there for constant speed or constant velocity. The speed time graph, this graph is very important. For velocity time graph, okay, this is for constant speed. That is, the speed or velocity is not changing. It will have some positive value. So this graph is going to be parallel to x-axis, and the area below this graph will give us the distance traveled. Suppose if you are asked in this particular graph, okay, see this time is there, this is 10 seconds, and here the speed is say 5 meter per second. This value is 5. Okay, if I want here how much is the distance traveled, this is going to be the rectangle, the area below this rectangle, the area of this rectangle is going to give us the distance traveled. Basically it is nothing but it will be speed multiplied by time. This is going to give us the distance traveled. It's going to be the area of this rectangle in this particular example. The next part is acceleration time graph. This is for constant speed.
So,
yes.
So B1, this velocity time graph, you find the acceleration with gradient as well as v minus v upon t, right?
If the speed is constant, its acceleration is 0. Speed is not changing. Very
yeah,
well.
but if there's incline, like
if it is inclined, if speed time graph is inclined, that is coming later. That's for accelerated motion. That's our next part.
Okay.
Now, acceleration time graph. Here the speed is constant, means there is no change in speed, so acceleration will be 0. The gradient of this graph will be 0. This will be the line that's going to be along x-axis. Here the acceleration is 0, so it is touching the x-axis. The next part is for constant acceleration. Distance time or displacement time graph will be a curve like this. This graph is a curve. Remember, this is distance time or displacement time graph. Now speed time or velocity time graph. Okay. If the speed or velocity is starting from some particular value, then this pink line is going to give you the speed time or velocity time graph for constant acceleration. There the speed or velocity is starting from the value 0. Okay. So here the speed is starting from 0, and of course in this case it's a speed time graph or velocity time graph. Here the value of gradient, this part is very important. The value of gradient will give you the value of acceleration. Okay. So the value of gradient in this graph gives us the value of acceleration. Again, here area below the graph is going to give you the distance traveled. Suppose if I'm going to consider this blue graph, suppose if I ask you, this is, say the time is 20 seconds. How much is the distance traveled in 20 seconds? You will make this triangle. This triangle is going to give you, the area of this triangle is going to give you distance traveled. So area below the graph gives us distance traveled, while the gradient, the slope, is going to give you the value of acceleration. Obviously, this is constant acceleration. It will have some particular value. Okay, this graph is also not so much important. It's constant acceleration, so it is a line that is parallel to x-axis.
Because in the marking generally they suggest the normal distance upon time.
Okay, it's a distance time graph. So here the gradient, the value of gradient is going to give you the value of speed.
Yes,
Okay.
so that's there, but according to the mark scheme, you show the formula, right? Like speed equals to distance upon time. You get 1
Either, yes, either you can use that, or you can write gradient is equal to y2 minus y1 upon x2 minus x1, and then whatever you get.
So I've sent you the picture.
Okay, I'll check that. So it's, if such a question is asked, between what time interval or at what time interval the object is not moving, it is between 20 seconds to 50 seconds. And for how much time if it is not moving, then your answer will be 30 seconds. The next question is find the maximum speed of the object. You can look at the graph. Here the gradient is greater. Okay, it's more vertical than this part. So therefore you'll find this gradient that is going to give you the maximum speed. Find the gradient at this point. You can see here this is 90. This is 30. For time axis, this is 50 and this is 60. So just y2 minus y1 upon x2 minus x1. This gradient, this is maximum speed is going to be 6 meters per second. This is our next question. For how much time did the journey last? So you can look at the graph.
60 seconds.
Correct. 0 is here. The graph is ending here. So it is, the answer is 60 seconds. Find the average speed in the entire journey. So total
It will be 3
distance.
meters per second.
Correct. Total distance traveled is 90. No. Total time taken is 60 seconds. This is your total distance, 90.
It will be 1.5. Yeah, it will be 1.5.
Correct. And here the time, total time is 60. So total distance, average speed is total distance divided by total time. Okay. Which is going to be 1.5 meter per second. Next question. After 30 seconds, the object was at what distance? "30 seconds is this. You look here like this and then you look here like this. After 30 seconds, okay, you go from here to here and then from here to here. The distance will be 30 meters. Okay. What is the speed of the object in the beginning? Who will answer this?
0.33 meters per second.
0.33 meters per second. Is that answer correct?
Silent will be 0. No.
Beginning part is this part. The value of distance is not changing. It means it is at rest. The speed is 0.
Yeah.
Distance is not changing.
Yes.
It's remaining 10 only. Distance not changing means speed 0. Between what time interval or intervals the object had stopped?
0 to 30.
Correct.
And 40 to 90.
From here to here it is stopped. This is 0. This is 30. And then from 40 to this part which is 90. So there are two intervals. Okay. 0 to 30 seconds and 40 to 90 seconds. During what time interval the object moved fastest? How much was its speed? So what you are going to do over here basically is just from looking at the graph you can't make out. At these both places the speed is 0. I have to calculate the speed in this region and the speed in this region. I'll calculate the gradient for this. I'll calculate the gradient for this, whichever is greater. Okay, find that value.